Hello and welcome to my channel. I am Mensa Augustine. Please, if you are new here, kindly subscribe to my channel. And if you have been watching my videos and if you're not yet subscribed, please kindly subscribe for us to build the mathematics community. In this lesson, we are going to talk about limits involving square roots. Now, we will look at the case where the numerator divided by the denominator upon direct substitution gives 0 divided by 0. If you have a function that contains square roots and you are taking the limit and you substitute the value of x straightly and you get the numerator to be 0 and the denominator to be 0, how do you evaluate it? Then we look at upon direct substitution, if the numerator goes to 0 but the denominator gives you a real number or a number which is not equal to 0, which is either less than 0 or greater than 0, what will you do? And then you look at where the numerator divided by the denominator upon direct substitution, the numerator remains a real number or gives a number greater than 0 or less than 0, but the denominator gives 0. So we can group it into 1, 2, 3, then 4, where the numerator and the denominator, you can factorize something out. If you can factorize something out, then it means that direct substitution will give you 0 divided by 0. So we have 1, 2, 3. So we have 3 cases. But I'll solve more examples so that it will help you to know how to evaluate different examples. Though we have to approach it using these 3 ways. So I'll first take example for this one. So let's look at this one. Our first question is, we are to evaluate the limits. We are to evaluate the limits for this marker. We are to evaluate the limits as x approaches positive 1, x cubed minus 1 divided by square root of x minus 1. So you see that here upon direct substitution, we are going to have 1 cubed minus 1 divided by square root of 1 minus 1, and it will give us 0 divided by 0. Here the numerator will give 0 and the denominator will give 0. So if this happens, how do we evaluate this limit? So here you have to note this one. You see that if we put in x equal to 1, the denominator gets to 0 and the numerator gets to 0. It means that x minus 1 is a common factor of the numerator and the denominator. Wow. So x minus 1 equal to 0, x will give you 1. So since when we put in x equal to 1, we are getting 0, it means that the numerator and the denominator has a common factor, and that common factor is x minus 1. So we have to evaluate this function to get the common factor and cancel it out. So let's see how we get that common factor. So here, let's take it. You have the limit as x approaches 1, x cubed minus 1 divided by square root of x minus 1. Now since we are dealing with the square roots sign, we will rationalize. So let's rationalize this. So we multiply the numerator by the conjugate of square root of x minus 1, and that is square root of x plus 1. And we multiply the denominator also by the same conjugate, that is square root of x plus 1. Now, let's multiply the top. We have x cubed minus 1 times square root of x plus 1. Then let's expand the denominator. With x times with x will give us x. With x times 1 will give us plus with x. This will give us minus with x. And this will give us minus 1. Then bring the limit as x approaches 1. Here, I did not expand the numerator. The reason is that each question has its own fix. Each question has its own fix. So as we solve plenty questions, then you note how you go about each. Now, so here we take the limit as x approaches 1, x cubed minus 1 times the square root of x plus 1, all divided by x minus 1. So you see that you've got x minus 1 at the denominator, but the top, we are here to get the x minus 1 there so that we cancel that common factor out. Here we have x cubed minus 1. So let's expand this using difference of two cubes. Now, if you have x exponent n minus 1, it is equal to x minus 1 times x exponent n minus 1 plus x exponent n minus 2 plus x exponent n minus 3 plus then we take 1. So here we have x exponent 3 minus 1. So this will give us x minus 1 times x exponent 2 plus x exponent 1 plus 1. That is what we get. You have this, so let's end this. So that's the expansion for this. So here we take the limit as x approaches 1, x minus 1 times x squared plus x plus 1 times the square root of x plus 1, all divided by x minus 1. So you see that you've got the common factor at the numerator and at the denominator. So you cancel that one out. You cancel that one out. Very simple as that. So here we are going to have this one as the limit as x approaches 1, x squared plus x plus 1 times the square root of x plus 1. And we know that the limit of a product is the product of the limits. So here we take the product of the limits. That will give us the limit as x approaches 1, x squared plus x plus 1 times the limit as x approaches 1, square root of x plus 1. So when we put in 1, you get here 1 squared plus 1 plus 1 times square root of 1 plus 1, and this will give us 3 times 2, and that is 6. Wow, very simple as that. Let's look at the next example. The next example, we are going to take this one. We are going to look at Amaka, it's not coming. We are going to look at this one. You take the limit as x approaches 0, x minus square root of x divided by square root of x. Here, if you put in x equal to 0, you get 0 divided by 0. So here it means x equal to 0. So here it means x is a common factor. So how do we figure that x out? Should we do rationalization? No, here we shouldn't rationalize. Because if we take the limit as x approaches 0, we can divide square root of x. We can divide it by each term. So we can divide each term by square root of x. So we take x divided by square root of x minus square root of x divided by square root of x. No need to factorize. Very simple as that. Wow. So what are we going to get? Here we have the limit as x approaches 0, x divided by x to the power half minus 1. And this is the same as the limit as x approaches 0, x exponent 1 minus half minus 1. And what is 1 minus half? That is half. So we take the limit as x approaches 0, x to the power half minus 1. And this is the same as the limit as x approaches 0, x to the power half minus the limit as x approaches 0, 1. So here it is the same as writing the limit of x as x approaches 0 to the power half minus the limit of 1 as x approaches 0. So here, as x approaches 0, we are going to have 0 to the power half minus 1, and it is negative 1. So here, the answer for this will be negative 1. So that is the limit x minus square root of x divided by square root of x as x approaches 0 is negative 1. Now let's move on. So I said that each question has its own tricks. So let's move on to the next example. Now let's look at this one. Here, if we take the limit as x approaches 4, and we have square root of x minus 2 divided by x plus 2. So upon direct substitution, we are going to get square root of 4 minus 2 divided by 4 plus 2. And that will give us 2 minus 2 divided by 6. That is 0 divided by 6. And that is 0. That's our answer. So the limit as square root of x minus 2. So the limit of square root of x minus 2 divided by x plus 2 as x approaches 4 is 0. That's all. Very simple as that. Now, let's move forward. Okay, let's look at this example. Here we are going to take this one. We have the limit as x approaches 9, x squared minus 8 divided by square root of x minus 3. How do we solve this one? Here, upon direct substitution, we are going to get 9 squared minus 8 divided by square root of 9 minus 3. And that will give us 9 squared is 81 minus 8 divided by 3 minus 3. And that will give us 73 divided by 0, which is undefined. So here, we have to simplify this one further to check whether we can do something. So here, since x equal to 9 did not give us 0 divided by 0, it means that when we simplify this, we will not get a common factor. If we rationalize this, we will not get a common factor. You see that when you put here and get 0 divided by 0, that means that there's a common factor. But in this case, if we put in x equal to 9, we had the numerator to be 73 and the denominator to be 0. So it means there is no common factor. So here, factorization will not work. So there's no need for us to rationalize. Then what do? That is what we are here. So what we are going to do is that we take the limit as x approaches 9, x squared minus 8 times 1 divided by square root of x minus 3. Wow. I know that the limit of a product is the product of the limits. So here we take the limit as x approaches 9, x squared minus 8 times the limit as x approaches 9 1 divided by square root of x minus 3. Very simple as that. So here, upon direct substitution, we're going to have 9 squared minus 8 times the limit as x approaches 9 1 divided by square root of x minus 3. And this one gives us 73 times the limit as x approaches 9, 1 divided by square root of x minus 3. Wow. Now, let's use the board. Let's use the board. I hope you are following the lesson. Yes. So what do we do? So if this happens, what we are going to do here is very, very simple. Should we rationalize this again to see whether this one will also give us something? If we rationalize this, what are we going to get? You will still get division by 0. If you rationalize this, you will still get division by 0. Let's rationalize it and see. We take 1 divided by square root of x minus 3 times square root of x plus 3 divided by square root of x plus 3. The top will become square root of x plus 3 and the denominator will become this times that will give me x, this times that will give me negative 9. And if you put in x equal to 9, you will still get division by 0. So, then what do we do? Okay, that is what we are going to do. Very simple. So, if this happens, you take the one-sided limit of this function. So, you take the left side limit and you take the right side limit, and then after that, you compare to see whether the limit exists or not. So, here we are going to take the limit of 1 divided by square root of x minus 3 as x approaches 9 from the right. And we will take the limit of 1 divided by square root of x minus 3 as x approaches 9 from the left. Wow. Get your calculator ready. We are going to use it. So here, let's take it. So we take the limit as x approaches 9 from the right. 1 divided by square root of x minus 3. So let's see. Then let's take them simultaneously. Then you take the limit as x approaches 9 from the left. 1 divided by square root of x minus 3. So let's put 9 here. Then, from the right side of 9, x is approaching 9 from the right. And here, x is approaching 9 from the left. Very simple as that. So, as x approaches, today my marker. Yes, I have the correct marker here. Let's repeat it. That's the one, it's very nice. I think it fell down. Okay, so as x approaches 9 from the right side, we have, let's take a number that is very, very close to 9. That's the definition of the limit. So let's take this number, 9.00001. And then as x approaches 9 from the left side, let's take 8.9999. So here we are going to take 1 divided by square root of x approaches 9 from the right. So 9.00001 minus 3. So point this on the calculator and see what you get. So 1 divided by square root of 9.00001 minus 3 will give us a very large number. This will give us 6, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5.1644. Wow. That is if we take 9.001. Then it means that if we take this number 9.000000001, which is very, very, very close to 9, this value will increase. this value will increase. So it means that as we approach 9 from the right side, the value of this function will increase without bound, and it will increase to a very large number. So we say that it will increase to a very large number, and that number that we are getting, or the numbers that we are getting, are positive. So the function will increase to positive infinity. Very simple as that. Remember, we have 73 here, so we will come and conclude. So here, as the number increases to positive infinity, or as the number increases to positive without bound, if we multiply 73 by a very large number, we will still get a very large positive number. So 73 times a very large positive number will still give us a very large positive number. So as x approaches positive 9 from the right side, 1 divided by square root of x minus 3 will approach positive infinity. Now let's look at from the left side. Wow, I hope you are enjoying the lesson. Let's look at from the left side. Now from the left side, we are going to substitute, we are going to take 1 divided by the square root of 8.1234 minus 9. Check that one also from your calculator. Sorry, minus 3. 8.1234. That one will also give us minus 5. This will give us minus 5,999. 1, 2, 3, 4. 1, 2, 3, 4. 0.83331. Yes. That is if we pick 8.999. So it means that if we pick 8.9999999, which is very, very close from the left of 9, it is very close to 9 from the left, we are going to get a number that is very large than this. But it is large what? Negative. So as we approach positive 9 from the left, the value of 1 divided by square root of x minus 3 will also approach negative infinity. It will decrease without bound. So here, this value will approach negative infinity. That is, it will decrease to a very large number. And we have 73 multiplying this. So we have 73 times negative infinity. So if we multiply 73 by a negative large number, we will still get a negative large number. Wow. So here, let's put 73 here. So 73 times the limit of 1 divided by square root of x minus 3. As x approaches positive 9 from the right side, we are getting positive infinity. And this one too, we are getting negative infinity. Very simple as that. Now, you can see that the right side limit and the left side limit are not the same. So since the right side limit and the left side limit are not the same, we say that this limit does not exist. The limit does not exist. Let's take another example. So if we have the numerator divided by the denominator, where the numerator is not equal to 0, but the denominator is equal to 0 upon direct substitution, then if you approach the question this way, I hope it will help you to get there. Okay. Now, we've solved almost all the 3 cases that I wrote, but let us solve more examples to improve our understanding on how to simplify questions. That is, how to evaluate the limits involving square roots. There are some tricky questions there that we need to approach some, and then when you get some, you also know how you approach the question. So let's have the limit as x approaches 4 square root of 8 minus x minus 2 divided by square root of 5 minus x minus 1. So this is the same as the limit as x approaches 4 square root of 6 minus x divided by square root of 4 minus x. Now here what do we do? If we rationalize the denominator, we will still get 4 minus x. So here, if we put in x equal to 4, we see that we are going to get square root of 2 divided by square root of 0, and that will be square root of 2 on 0. So which means that what will help us? We have to use the product rule here and then take the left-sided limit and the right-sided limit of this. But watch as I do the right-sided and the left-sided limit of this, because it will give us something very, very unique than the first one that we've done. So here we use the product rule, we take the limit as x approaches 4 square root of 6 minus x times the limit as x approaches 4 1 divided by square root of 4 minus x. Then here, if we substitute x equal to 4, we have the square root of 4 minus 2 times the limit as x approaches 4 1 divided by square root of 4 minus x. And this will give us root 2. Oh, sorry, this is 6. And this is 4. So this will give us root 2 times the limit as x approaches 4 1 divided by square root of 4 minus x. So now what we do? We take the left-sided limit and the right-sided limit of 1 divided by square root of 4 minus x. So you take your calculator. So you take the right-sided limits first. On the right, 1 divided by square root of x. 4 minus x. So here, if we take 4, as x approaches 4 from the right side, value is very, very close to 4. Let's take 4.00001. So here, we are going to have this as 1 divided by square root of 4 minus 4.00001. Wow. So use your calculator to punch that one. When you are punching it with your calculator, put your calculator into complex, because this will give you a complex number. We have a square root and 4.0001 is greater than 4. So it will give us, okay, let's punch what is inside here first. We punch 4 minus 4.00001. We are going to get negative 0.0000123 think 0001. Yes. So we move 1, 2, 3, 4, 5. So we are going to get a negative number under it. So we put your calculator into complex number mode before you punch the whole of this. So if you punch 1 divided by square root of 4 minus 4.00001, 4 zeros, right? Okay. We are going to get, as I wrote first, that's 4 minus 4.12341. So that will give us 1 divided by square root of 1, negative 1 over 100,000. 1, 2, 3. So this one can be simplified as 1 divided by square root of negative 1 divided by square root of negative 100, square root of 100,000. So because we have 1 here, this one will turn upside down. So we are going to have 100, 1, 2, 3 divided by square root of negative 1. Wow. So this is the same as 100, 1, 2, 3 this is under the square root, divided by square root of -1. And then if we rationalize this, that is, if we multiply here by square root of -1 and multiply here also by square root of -1, we are going to have square root of -1 times 100,000 all divided by -1. And what is square root of -1? Watch my video on complex numbers from the description. The square root of -1 is I. So we're going to have I times the square root of 100,000 all divided by -1. And that will give us -I times square root of 100, 100,000. So here, what do we see? We picked 4.00001. In fact, I'm just doing this simplification to improve your understanding. You could have used the decimal point there and then you point 1 divided by 8. But whenever you're doing that, you have to put your calculator into a complex number mode. If you're doing that, put your calculator into complex number mode. Here, I'm simplifying it without the calculator. So you see that when we point square root of 100,000, square root of 100,000 will give us 3.16. So it means that if we pick a very close to 4, it will give us a very large number. A very large number. And the number will always be positive. And we have -I here. So you're going to have -I times a very large positive number here. So here, as we approach 4 from the positive side, this limit will approach -I times infinity. Now let us approach it from the positive side. So if we take the limit as x approaches 4 minus, that is from the left side, 1 divided by square root of 4 minus x. So from the negative side or from the left side, let's say from the left side. So if I take 4, from the left side of 4, I can get 3.9999. So here I'll take 1 divided by square root of 4 minus 3.9999. So let's point that one and see. This one, don't put it into complex mode because 3.99 is less than 4. So you take 1 divided by square root of 4 minus 3.9999. And that will give us 100. So this will give us 100. This will give us 100. Which means that if we take value very close to 4, it will give us a very large number. So as we approach 4 from the left side, this will increase without bound. So it will increase to a positive large number. Very simple as that. So here, you can say that if we take root 2 times the limit as x approaches 4 from the left, if you replace this function by f of x will also be what? From the left will approach positive infinity. And then we got square roots. Okay, let's multiply it by the square root. Square root times the positive infinity will go to the same positive infinity. And then square root times the limit as x approaches 4 from the right, f of x, where f of x is 1 divided by square root of 4 minus x, will approach -I times infinity. Very simple as that. Because if we multiply root 2 by infinity, you will still get infinity. And -I times infinity will be -I times infinity. Very simple as that. So this is also a special case where the square root is giving us complex numbers. Now, we've come very far, but let's try to evaluate more. Now, let's consider this one. We take the limit as x approaches 0, 2 divided by h times square root of 4 plus h minus 1 divided by h. Here, I hope that's the question, right? Yes. So here, as h, not x, as h approaches 0, if we put in 0 here, this one will be 0, 2 divided by 0, yes, and this one will be 1 divided by 0. So, what are we going to get? 2 divided by 0 minus 1 divided by 0 is our what? This one becomes undefined. So what do? Let's simplify what is inside there further. So what we are going to do is that here, yes, the limit, the question is to the power 1 out of 3. So let's do it. So here we take the limit as h approaches 0, then the LCM of this is h times square root of 4 plus h. So this one and that, this will divide this 1 times 2, we get 2. H will come and cancel h, then multiply this by 1, have negative square root of 4 plus h. Very simple as that. Now, to the power 1 out of 3. Wow. So we take the limit as h approaches 0, 2 minus square root of 4 plus h divided by h times square root of 4 plus h times 2 plus square root of 4 plus h divided by 2 plus square root of 4 plus h. That is the conjugate of 2 minus square root of 4 plus h. Because when you reach here, as h approaches 0, if you put 0 here, this will still be 0 divided by 0. So that's why we are continuing. Now, 2 times 2 here will give us 4. 2 times this will give us plus 2 square root of 4 plus h. This time that will give us minus 2 square root of 4 plus h. This time that will give us minus 4 plus h. Because the square root will cancel the square root. All divided by, here we are not going to expand because you have h here. So we take h times square root of 4 plus h times 2 plus square root of 4 plus h. Very simple as that. Here I said we are not going to multiply through because when we reach here, if we put h equal to 0, we have 0 divided by 0. So it means that h will be common to the numerator and the denominator. So here this one will cancel this. Then let's bring the limit as h approaches 0. Then bring 1 to the power 3. Oh, sorry, 1 out of 3 rather. To the power 1 out of 3. So this one will become the limit as h approaches 0. Here we are going to have 4 minus h all divided by h times square root of x square root of 4 plus h times 2 plus square root of 4 plus h all to the power 1 out of 3. So I'm going to have the limits as h approaches 0, negative h divided by h times square root of 4 plus h times 2 plus square root of 4 plus h. Now this one will cancel this, so we have the limit as h approaches 0, negative 1 divided by square root of 4 plus h times 2 plus square root of 4 plus h. So here as h approaches 0, what do we get? We send the limit inside, so we have the limit as h approaches 0, negative 1 divided by square root of 4 plus h times 2 plus square root of 4 plus h to the power 1 out of 3. So this will give us negative 1 divided by square root of 4 plus 0 times 2 plus square root of 4 plus 0 all to the power 1 out of 3. And that we are going to have negative 1 divided by 2. 4 plus 0 is 4, root 4 is 2, times 2, 4 plus 0 is 4. Root 4 is 2. All to the power 1 out of 3. And that will give us negative 1 divided by 8. All to the power 1 out of 3. And that will give us negative 1 out of 2 as our final answer. That is, the cube root of negative 1 out of 8 is negative 1 out of 2. Now, let's move on. I hope this lesson is very cool and it will improve your understanding. Now let's look at this one. The question that I have here is the limit as h approaches 0, 1 divided by h times the square root of 1 plus h minus the square root of 1 minus h. Okay, let's try this one. Here, if we put in h equal to 0, we have 1 divided by 0, which is indeterminate, times this. And that one will also be, this will be 0 divided by 0. So here, it means that h is a common factor. So since h is a common factor, what do we do? There's no need sending this h inside. So let's rationalize what is inside. Okay, so here you have the limit as h approaches 0, 1 divided by h times square root of 1 plus h minus square root of 1 minus h times square root of 1 plus h plus the square root of 1 minus h, all divided by square root of 1 plus h plus square root of 1 minus h. So you multiply the top. So you have the limit as h approaches 0, 1 divided by h. This time that will give us 1 plus h. This time that will give us plus square root of 1 plus h times square root of 1 minus h. This time that will give us minus square root of 1 plus h times square root of 1 minus h. And this time that will give us minus into bracket 1 minus h. All divided by square root of 1 plus h plus square root of 1 minus h. And you see that this one will cancel this. Very simple as that. And we are going to have the limit as h approaches 0, 1 divided by h times 1 plus h minus 1 plus h, all divided by square root of 1 plus h plus square root of 1 minus h. So this will give us the limit as h approaches 0. Very simple as that. 1 divided by h. This will cancel this. Then we have 2h all divided by square root of 1 plus h plus square root of 1 minus h. And here we're going to have the limit as h approaches 0. This h will cancel this h. You have 2 divided by square root of 1 plus h plus square root of 1 minus h. As h approaches 0, I'm going to have 2 divided by square root of, if this is 0, you have square root of 1, that is, and if this is 0, you have plus square root of 1, and that will give us 2 divided by 2, that is 1. Because square root of 1 is 1, 1 plus 1 is 2, 2 divided by 2 is 1. Very, very simple as that. This lesson is lengthy, but I think it will improve your understanding, because I've seen that I've been increasing your appetite to stay tuned and watch because of the examples that I'm giving. Now let's solve this one. We are going to look at this one, the limit as x approaches 0. square root of a plus dx times c plus dx minus square root of ac all divided by x. Yes, I think that is the question. Here we are saying that a, b, and c are subset of positive real numbers. So here, if we put in x equal to 0, b times 0 will be 0, d times 0 will also be 0, and we have square root of ac minus square root of ac will be 0. So we have 0 divided by 0. So it means that x is a common factor, because if we put in x equal to 0, we are getting 0 divided by 0, so x is a common factor, and we have x at the denominator side. So let's see whether we can get x at the numerator and cancel the common factor x out. So we will take the square root of a plus bx times c plus dx minus square root of ac times square root of a plus bx times c plus dx plus square root of ac, that is the conjugate, all divided by x times square root of a plus bx times c plus dx plus square root of ac. Then bring the limit as x approaches 0. So here, this will multiply that and we'll get what is inside. You get a plus bx times c plus dx, or the square root and the square root will go, minus square root, plus square root of a c times square root of a plus bx times c plus dx. Then this time this will give us minus square root of ac times square root of a plus bx times c plus dx, and then minus with ac times positive with ac will give us minus ac, all divided by x times square root of a plus bx times c plus dx plus square root of ac. Wow! Just come and enjoy the lesson. Then we bring the limit as x approaches 0. Now, this one will cancel this out. Then we have the limit as x approaches 0. Now let us expand this. AC plus ADX plus BCX plus BDX squared minus AC, all divided by x times square root of a plus bx times c plus dx plus square root of AC. And here this AC will cancel this AC. So we have the limit as x approaches 0, a dx plus bcx plus bdx squared, all divided by x times square root of a plus bx times c plus dx plus square root of ac. Now as x approaches 0, what do? We can factorize the x out. So we take the limit as x approaches 0, x times AD plus BC plus BDX, all divided by x times square root of a plus bx times c plus dx plus square root of AC. And what will happen? This x will cancel this x. Wow! So as x approaches 0, we are going to have AD plus BC. AD plus BC. Because if we put 0 here, this one will become 0. If we put 0 here, this one will become 0. If we put 0 here, this one becomes 0. So you get the denominator as root A times root C plus root AC. And that will give us AD plus BC divided by root AC plus root AC. That will give us AB plus BC divided by 2 root AC as the final answer for the limit as x approaches 0, square root of a plus bx times c plus dx minus square root of ac divided by x. Now, I think we've solved more examples, and should we end here? Okay, let's solve the last two examples, and then I will say bye bye. I'll say bye bye, bye bye, bye bye, bye bye, bye bye. Okay, let's take this one. We have the limit as x approaches m. X minus square root of mx divided by x minus m. So here, what do we do? If we put x equal to m, we are going to have here as m minus square root of m times m will be m squared divided by m minus m, and that will give us 0 divided by 0. For this square will cancel the square root. So here, since we put x equal to m, it means that x minus m is a common factor. So let's rationalize and find x minus m and cancel it out. So here we take the limit as x approaches m. And here we are saying that m and x are greater than 0. So here m and x are greater than 0. If they are not greater than 0, this will give us a complex number. So we take x minus square root of mx divided by x minus m, and the conjugate of x minus square root of mx is x plus square root of mx, x plus square root of mx. So we multiply this by that, we have x squared plus x square root of mx minus x square root of mx plus, minus mx. Negative times positive is negative. Square root of mx times square root of mx will give us mx. All divided by x minus m is a factor, so there's no need expanding. So you put x minus m times x plus square root of mx. So here this one will cancel this. Take the limit as x approaches m. We have the limit as x approaches m, x squared minus mx divided by x minus m times x plus square root of mx. And that will give us the limit as x approaches 0. You can factorize x out at the numerator, all divided by x minus m times x plus square root of mx. And this will give us the limit as x approaches 0. X minus m will cancel x minus m. So we're going to have x divided by x plus square root of mx. Now as x approaches m, not 0. Yes, as x approaches m, we are going to have m divided by m plus square root of m times m. And that will give us m divided by m plus square root of m squared. Wow. And this will give us m divided by m plus m, and that is m divided by 2m, 1 divided by 2. Wow. That's our final answer. Very, very, very simple as that. Now the last example, and I will say bye-bye. The last example, and I'll say bye-bye. Now, What about this one? If we take the limit as x approaches 0, 1 divided by square root of x plus 9 minus 1 divided by 3. So let's do direct substitution and see. This will give us 1 divided by square root of 0 plus 9 minus 1 divided by 3. Earlier 1 divided by square root of 9 minus 1 divided by 3. This will give us 1 divided by 3 minus 1 divided by 3. And that is 0. Very, very simple as that. Thank you for watching, and I hope I have added something to what you have already. Bye bye, and subscribe to my channel.